Okay, so yesterday we discussed the procedure for calculating the flux, right? So that is flux density d bar using Gauss law. So there are 5 steps, okay, 5 different steps we have to follow, right? Once just a brief recap of what is that. So first step will be to choose the Gaussian surface that matches with the given charge distribution. If it is right, for example, if it is a line charge, we'll choose a Gaussian surface that suits its geometry. So first is we have to choose the Gaussian surface. Then we have to take the appropriate coordinate system that matches with this Gaussian surface. Okay, so the coordinate system that we take should match with the the Gaussian surface that we have taken. Okay, so this is the second point. After that, then in the taken coordinate system, identify the normal plane, the plane which is normal to the flux, right? So normal to the flux produced, so the plane which is normal to the flux produced have to be taken, and you have to write the equations of d bar as well as ds bar. D bar is the required flux density, right, and ds bar is the surface, right, area of surface. So we have to write the expressions for d bar and ds bar in the given coordinate system. Okay, once we do that, right, take the dot product of d bar dot ds bar. So once we get the knowledge of what is d bar, right, and what is ds bar, one very important hint that we have to remember is d bar and ds bar should always be taken in the same direction, in the same coordinate. Okay, that means if I take d bar in let's say x direction, ds bar also comes in x direction. Okay, the only question is we have to identify what is a normal plane, right? The plane, the axis that is normal to the surface, right, charge. So this is the most important thing. Once you do that, d bar and ds bar should be written in the same direction itself. Okay, for example, if I choose d bar in x coordinate, ds bar also should be chosen along x, that is dsx. Okay, so once I take this these two things, then I take the dot product of these two, that is d bar dot dsx. Okay, so ds bar, take the dot product and then take the integral d bar dot ds bar. Okay, so integral d bar dot ds bar is what we call it as per the Gauss law, this is nothing but q. Okay, so q or psi, right? Psi, it is generally psi is represented as integral d bar dot ds bar, or that is also equal to q. Okay, so here d bar is the unknown term, right? Q or flux we have to measure, q or flux, right? So q or flux can be measured, right? If you measure q or flux, that is psi, then d bar is the unknown, ds bar is known because we know what is the surface, right? The Gaussian surface, we have chosen our Gaussian surface. So what are the parameters of the Gaussian surface, you know. Okay, so right, and solve this equation for d bar, solve for this equation for d bar. Once we get d bar, we can calculate the e bar as well. Okay, so this is the general procedure for calculating the thing. Okay, I'll repeat the steps again one more time because this is very important. A question will come in the exam from this topic itself, right? This is the most important topic of this part. Okay, Gauss flux and flux density. So first what we have to do, we have to choose the Gaussian surface, okay, that matches with the charge particle, right? So you don't need to worry, the charge particle or the charge value, the q value or flux value, we have to calculate first. Okay, take the Gaussian surface, you have to calculate the number of flux lines, or you have to calculate the q that will be given in the question itself. You don't need to worry, they will be giving question in q in the question itself. Okay, so q in the question itself will be given, q or psi. From that we need to calculate the flux density or electric field intensity. How to do that? This is the procedure. Okay, first choose the Gaussian surface, right? Then choose the appropriate coordinate system that matches with the Gaussian surface. Then third step, calculate identify the normal plane and write the expressions for d bar and ds bar in the normal plane. Okay, once you have done that, take the dot product, integrate it. Okay, integrate it and equate it to the q value, right, as per Gauss law. So once you do that, the unknown here is d bar, you know ds bar, you know q, right? You will calculate the d bar. Clear with this? Okay, right. So let us see how we can apply this. So I will take the first example as infinite line of charge, infinite line charge. So already using Coulomb's law, we have calculated the expression of E bar, okay, the electric field intensity due to infinite line charge. Okay, the same thing we are doing here using Gauss law. Okay, so how to do that? Let us see. Okay, so the same value, we should get the same value that we got earlier, right? Okay, I think all of you remember the calculation of E bar due to that is electric field intensity due to line charge. Okay, I hope that you remember it clearly, right? So okay, so clearly I think you remember it. So again, I'm repeating that I'm not going to repeat it, but I'm going to see how we can calculate using this particular thing, right? Okay, so yeah, let us go for it. Let us go for this particular thing. Some people have joined. Okay, yeah, joined. Okay, right. So let us consider an infinite line charge, right? So infinite line charge will look like this. So it is a line charge basically. So line charge, we can assume an infinite line charge like to be like this. So it's a line of charge. It's like a wire. Okay. So I am having an infinite line charge. Okay. So the length of this line charge will be infinity. Okay. That's why we call it as infinite line charge. Okay, right. One more person is waiting. 1 second. Yeah. Infinite line charge. Now, first step. What is the first step in our process? The first step is we have to identify a Gaussian surface that matches with the symmetry or the structure of this line charge. Okay, so because a wire is nothing but a small cylinder, okay, so a wire or a line is basically a cylinder of radius 0. So the symmetry that matches with this is obviously going to be a cylinder. So I'll consider a cylinder, a cylindrical surface as a my Gaussian surface, a closed cylinder as a my Gaussian surface, like this. Okay, so this is my Gaussian surface, a cylinder, right? A cylinder. Let us assume that the radius of this cylinder is r. Okay, small r or capital R, whatever it is. Small r or capital R is the radius of the cylinder, right? Let the height of the cylinder be, let's say, small h or z. We can assume whatever it is. Okay, so small h or z is the height of the cylinder. Okay, r is the radius of the cylinder, h is the height of the cylinder. Okay, now, so that is the first step done. So I have been given an infinite line charge. Let this line charge be having a charge of q. Okay, the charge of this particle is q. Okay, and let us assume that psi is the flux that is coming out of this Gaussian surface. Okay, so in the problems they will give you what is the value of q or psi. Okay, okay, clear with this? So this is the setup, right? We have the first point. Okay, first point is, so we are given with an infinite line charge. The length of the charge is infinity, right? Because the charge of this particular line is q, and let us assume that rho l is the line charge density of this particular material, rho l. Okay. And psi is the flux that is coming out of this particular material. Okay, right. Now if I consider, okay, if I take the Gaussian surface that matches with the symmetry of this line charge, it will be a cylinder. Okay, so I'm considering a cylinder. The height of the cylinder is h and the radius of the cylinder is r. Okay, 1 second. The height of the cylinder is h and the radius of the cylinder is r. Okay, so now that's the first step done. The second step, what is the second step? Second step is we have to choose the coordinate system that matches with the symmetry of the Gaussian surface. Obviously, because it is a cylinder, so I'll choose cylindrical coordinate system. Okay, So in cylindrical coordinate system, what are the coordinates we have? Right, we have three coordinates. They are, one is the height of the cylinder, that is z axis, z coordinate, and then the other coordinate is the r coordinate, that is the radius of the cylinder, r. So you represent a cylindrical point as r comma phi comma z, right? So I'm choosing, the second step is I'm choosing the coordinate system. The coordinate system that I'm choosing is the cylindrical coordinate system. Cylindrical coordinate system. So in cylindrical coordinate system, we have the three axes as z axis, r axis, and phi axis. Okay. So second step is also done, right? So first step is choose the Gaussian surface that matches. One second. Choose the Gaussian surface that matches with the symmetry of the charge particle. Done. Second, choose the coordinate system. Done. Right. Now the third step, the most important step. The third step is the choosing of normal plane. Right. Now, if what is the normal plane? There are three planes here. Right. There are three planes here. For a cylinder, if I take a cylinder, let's say the pen is a cylinder. This is a cylinder. Okay. The cylinder has three planes. Correct. What are the three planes? One is the top plane, other is the bottom plane, and the side plane. Okay, the sides. Okay, we cannot consider as four because all this is not a rectangular box, it's a cylinder. So this particular thing is only one. Okay, understood? So if I consider this as my Gaussian surface, right, Gaussian cylinder. So every cylinder has three surfaces. What are the three surfaces? One is the top surface, other is the bottom surface, or you can consider this as, this also can be considered as one. But because they are separated, physically separated, we consider this as top, this as bottom, and these are the side surface. Okay, so there are three surfaces here: top surface, bottom surface, and the sides. Okay, clear with this? Understood? Right. So okay, out of this, right, we have to consider one surface which is normal, right, or the surface from which the flux can flow out. The point is, what is a normal surface? Normal surface means the flux should come out of the surface. Okay, so see here, because this is an infinite line charge, right, the length of this line charge is infinity. Okay, so the length of this line charge is infinity. So therefore there will be no flux coming out from this. Is there any possibility? No, because, and even if it comes, if it comes, let us say it will be coming in this side or this side like this, because the line charge is of infinite length of the line charge is infinity. Okay, so there is no closing and opening led ikkada. There is no opening here or there is no opening here, right? Whatever the flux comes out of this, whatever the field that is coming out of the charge will only come from side movement. Okay, I hope I'm clear, right? So I'll repeat it again. See here, the line charge that you are considered is of infinite length. Okay, Gaussian surface that you have considered is a finite one. Gaussian surface manam teeskuntundi, it's of finite height. Okay, so this Gaussian surface is not completely enclosing the infinite line charge. Okay, so kabatti, right, there is no possibility of flux coming out from the top or bottom surface. Okay, so the flux that is coming out of top or bottom will be zero. Okay, there is only possibility that the flux will come out of side surfaces, from the side. Okay, so there is no other possibility, right? So therefore the normal plane that we have to consider is the side plane. Okay, right, the normal plane that we have to consider is the side plane. Side plane is the plane that we have to consider as normal, right? Normal plane. Okay, I think I'm clear, right? So now what is the coordinate? What is the coordinate that matches with the side plane? What is the coordinate that is along the side line, along the side? So right, so see, this is the height, z axis. The z axis is representing the height of the cylinder, so it is not in the normal direction, definitely not in the normal direction. Okay, so phi axis is the azimuth angle. Phi is the azimuth angle. Azimuth angle represents, as I said, the angle made by a particular point with the center. Okay, so that is it can be like this. It can be like this. So what is right rotation? Okay, so if I consider this as a cylinder, so this is what it is. Okay, right. So when I consider like this is not making normal. Is it making 90 degrees or 0 degrees? No, right? So the surface or the coordinate that exactly represents the normal plane is this one. And exactly coming out from the center radius, right? This plane, R plane. Okay, right? So when it comes exactly like this out of the Gaussian surface, the flux lines that are coming out of this Gaussian surface in this direction or in this direction is what we call it as normal planes. Understood? So we cannot call this as normal. Can you call this as normal? This is phi plane. This is phi. Okay. This is the phi axis, right? So phi axis cannot be called as normal plane. Z-axis definitely you cannot call it as normal plane. Phi axis definitely cannot be called as normal plane. Why? Because the angle, there is some angle. Angle should be either 90 or 0. 90 means like this, 0 means like this. 90 is not possible, so only 0. So that 0 angle represents the R axis. Okay, when phi is equal to 0, you call it as R axis. Okay, so therefore the side or the normal plane that we have to consider is the R plane, that is R axis. Okay, so I have to consider the D bar along R. Okay, is it clear? The third point, understood? Right, so the D bar that I have to consider is along the R plane. So therefore D bar I can write it as dr AR. Okay, I think I'm clear with this. Okay, similarly ds bar is also written as, so ds bar should also be taken in the same angle, okay, in the same direction. So the direction that we have considered here is R. So DSR. So I think we know when we have written the cylindrical coordinate systems, so surface area change, the change of surface area along R can be written as R d phi dz AR. Okay, so the surface area change along R is nothing but R d phi dz AR. Okay, so the third step is also done, right? This is the third step. Okay, so just quick recap of what we have done till now. Okay, so quickly let us see and let us go to the fourth and fifth steps. Okay, so I have considered an infinite line charge. Infinite line charge means a line charge having a length of infinity. The length of the charge is infinity. Okay, so it is having infinite length. Okay, so this line charge or a wire basically looks like a cylinder. Okay, so it is having the structure or the symmetry as that of a cylinder or a wire. Okay, so therefore the Gaussian surface that I have chosen is also cylindrical, is also a cylinder. So like this. Okay, so that is the first step done. Second step is, obviously it's not a very informative one, but because we have chosen a cylinder as a Gaussian surface, the coordinate system also that I choose is right cylindrical coordinate system, and there are three axes: R axis, phi axis, and Z axis. The point will be represented as R phi Z. Okay, right. Now once this is done, the third important and the most important step is how to choose the normal plane, which is the normal plane. Okay, so for the Gaussian surface there are three planes or three surfaces. Okay, the three surfaces are, one is the top surface, other is the bottom surface, and the third surface is the sides, the sides, okay, of the cylinder, sides of the cylinder. Okay, so in this, out of this we have to choose one, right? One from which the flux flows. Okay, ante manam ela తీసుకున్నాం అంటే ఫ్లక్స్ అనేది ఏ డైరెక్షన్ లో ఫ్లో అవుతుందో చూస్తున్నాం. ఓకే, సో ఎలా చూస్తున్నాం? ఫస్ట్ ఇఫ్ ఐ టేక్ ద టాప్ సర్ఫేస్ తీసుకున్నాం అనుకోండి, ఈ టాప్ సర్ఫేస్ దగ్గరికి మనకి ఇంకా ఇన్ఫైనైట్ లైన్ చార్జ్ అనేది ఫినిష్ అవ్వలేదు, సో ఈ బయటకి రాదు. ఓకే, అంతే కదా. సో ఇన్ఫైనైట్ లైన్ చార్జ్ అనేది ఇంకా ఫినిష్ కాలేదు కాబట్టి దెర్ ఇస్ నో పాసిబిలిటీ ఆఫ్ ఫ్లక్స్ ఫ్లోయింగ్ లైక్ దిస్. ఇలా ఫ్లో అయ్యే ఛాన్సెస్ లేవు. ఓకే, That's what Gaussian surface lonchi ila బయటికి వచ్చే chances లేవు. Are you getting my point? So kabatti this surface cannot be taken as normal surface. Similarly, this whatever that bottom surface I consider, this is also not closed, right? And not completely enclosing this line charge. Kabatti here also there is no possibility of flux flowing like this. If it flows like this, it's called it can be taken as normal surface, but it is not flowing like this. It cannot flow like this because the line charge is not ending there. Okay, so the only possibility is the flux will be coming out like this. This is the way that the flux can come out, okay, of the Gaussian surface, right? So therefore this plane, the sides plane are the side plane is the plane that is normal. So that is how I've decided. Now what is the axis that is representing this side plane? ఈ side plane ను represent చేస్తున్న axis ఏంటి? Z axis అయితే కాదు, ఎందుకంటే it represents the height of the cylinder. Okay, right. Then there are two possibilities, phi or R. Phi axis kuda kaadu. Why? Because phi represents certain angle, right? And the phi axis lo enti, you are talking about the angle, right? It can be like this, it can be like this, it can be some completely like this, arbitrary, right? When I get something like this, this is not normal, right? So normal ga ravali ante the flux line should make 0 degrees, right? Are you getting my point? This right, this whatever the flux that is coming, if I say this as normal, that means it should make 0 degrees with the, right, 0 degrees with the side of the cylinder. Then only it is possible, then only you can say it as normal surface. Otherwise you don't call it as normal surface. Okay, so therefore this the axis that is making the axis that is normal to this cylinder is the R axis. Okay, done. So I have to write the d bar and ds bar in the normal plane, which I have written dr ar, dsr is this thing, right? The next thing is we have to write the next step will be we have to take the dot product of this. So when I take the dot product d bar dot ds bar, the dot product will be, so ar dot ar is 1, right? Ar dot ar is 1, so the magnitudes get multiplied. So right, dr, okay, into r into d phi dz, okay, into d phi dz, right? Okay, so d bar dot ds bar will be like this. Okay, now take the integral, the closed surface integral of d bar dot ds bar. D bar dot ds bar will be nothing but the integral of dr. It's a surface integral, so I'm writing s, so dr into r into d phi dz. Okay, so this is the thing, right? Clear? So this is the next thing. Okay, now what I do now, so this as per the Gauss law, I can consider this as phi or q, whatever it is, right? Phi or q. So phi or q is equal to, right, phi or q is equal to, so integral, right, integral, surface integral dr r d phi dz. Okay, so I am integrating, this is basically surface integral means double integral, so one with respect to phi, okay, and another with respect to z. Okay, so right, we have to double integrate it, so dr d phi dz. Okay, so this is equal to, right, now dr and r are both right, we can consider these two as constant with respect to phi and z. Okay, both of them are constant, so right, phi and z d phi dz. Okay, d phi dz. Now this is equal to, right, this is equal to dr r into, so if I integrate, there is only one, so integration of 1 with respect to d phi is phi, and what are the limits of phi? So we know that the phi varies from 0 to 2 pi. Okay, so phi, the phi angle varies from 0 to 2 pi, and similarly the integration of 1 dz is z, so z, right, and what is this z? This Z is the height of the Gaussian surface that you have considered. Okay, so you can assume the Gaussian surface, the height of the Gaussian surface as minus h by 2 to h by 2 or 0 to h. Okay, understood? So right, I'm repeating it again. So this is d bar dot ds bar. So when I take the dot product, I'll get like this. AR dot AR will become 1. Okay, then integrate this, I'll get like this. Right, now as per Gauss law, this will be equal to psi, okay, or q. Right, for the time being, let us consider it as psi. Okay, right, psi is this. Okay, so psi is equal to, right, what I get is integral dr or d phi. Okay, so now this is closed surface integral, means representing double integral. One integral is done with respect to phi, other integral is done with respect to z. Okay, so I'll get like this. Okay, now after this dr and r are constant, so I'll put them out. Okay, so integrating with respect to phi, d phi with respect to dz, so the integral of d phi will be phi. Okay, limits of phi, as we know, the limits of phi, the surface of the complete structure of the cylinder, so there is a variation of 2 pi radians, so 0 to 2 pi. Okay, right, and the z, dz, which is z, right, and the limits are, we have to consider, we are taking the Gaussian surface, right, so the height of the Gaussian surface is h, so 0 to h. Okay, right, so I think, have you noted down, right, till now? Okay, so this is clear. Okay, so I hope this is clear and written. Okay, all right, now let us continue with this. Okay, so therefore this is psi is equal to dr into r, right, phi, if I substitute 2 pi minus 0 is 2 pi. Okay, and h, okay, 2 pi h or z, whatever you can consider. So the unknown that I want is dr. Dr is equal to psi divided by, right, 2 pi r into h. Okay, so this is the, right, dr. Okay, now we know that as per Gauss law, we can write psi as q, or for a line charge we can write it as integral rho l dl. Okay, so integral rho l dl, right, so therefore we can write this as dr is equal to rho rho integral rho l dl. Okay, integral rho l dl divided by 2 pi r into h, or I can write this as, because the length here we are considering it as r, so rho l by 2 pi h. Okay, right, r gets cancelled, right. Okay, so integral dl, again integral dl means, right, in l, what is l here, the length of the yeah, rho l, length of the thing, so I'll get like this. Okay, right, now this is the dr, right, this is the magnitude of the dr, so therefore d bar will be, the flux density d bar can be written as dr into ar, right, correct, so therefore that is equal to, right, dr is this, the magnitude is rho l by 2 pi h into ar bar. Okay, this is the, right, expression for electric flux density, right, of an infinite line charge. Okay, so this is how we can apply the Gauss law to find out the electric flux density, right, from, if I know d bar, we can calculate e bar, how we will see just in a second. Okay, is this clear? So I think this is I hope that this is clear, right? Okay, so just if there is any doubt in this, you can just ask me, right, quickly we will take any doubts if there are any doubts. So some people are again waiting, we'll just add them. Any doubts, just if you have any doubts, you can post it in the comment section. I'll repeat it again. Okay, no issues if you want me to repeat. Yeah, any sir, please, and remember, sir, how the in integral one is r, sir, I didn't understand. Integral l, acha acha, you are this, so if I put rho l into, Yeah, you're talking about this, right? So rho L is basically constant. So if I write like this, dl, integral dl, this is nothing but L representing the length of the line, or the length of the Gaussian surface, the length of the line. So this we can consider some arbitrary, right? Otherwise also no issues, you can stop here itself. So you can put this as L, some rho L into L, right? If you're getting confused, right, you can write, you can stop it here itself also. Okay, so rho L by 2 pi r h, right? So again same thing, right? Okay, so integral dl is what we can write as L. Okay, if you feel confused, you can just write, replace psi is equal to q. Anything is okay, anything is fine. Okay. Anything else? Anything else? Can you explain again from integral? Okay. Yeah, just a second. So I'll explain the entire repeat entire process again. Okay, so just, yeah, quickly let us quickly recap it again. See, first step is understood, I think. First step is choice of Gaussian surface. Because the line looks like a cylinder, I have chosen a cylindrical Gaussian surface. That's clear. Okay, second step is we have to choose the coordinate system. That is also clear, I think. Coordinate system, we have to consider cylindrical coordinate system, because cylindrical coordinate system matches with the Gaussian surface. Okay, so that second point is also done. Now the third point is, so normal plane, the choice of the normal plane. So I think there are three, this is also clear. Okay, there are three planes here, there are three surfaces here: top plane, bottom plane, and side plane. Top plane and bottom plane cannot be taken as normal, because the Gaussian surface is not completely enclosing the line charge. Okay, complete గా enclose చేయట్లేదు కాబట్టి ఫ్లక్స్ అనేది బయటికి ఇలాగాని రాదు. సో కాబట్టి మనం Gaussian surfaces గా వీటిని నార్మల్ సర్ఫేసెస్ గా తీసుకోలేము. ఓకే, సో కాబట్టి మనం ఏం చేస్తున్నాము, ఓన్లీ నార్మల్ పాసిబిలిటీ ఏంటంటే నార్మల్ గా రావాలి బయటికి, అంటే 0 degrees తో రావాలి ఫ్లక్స్ వచ్చిన ప్లేన్ నే నార్మల్ ప్లేన్ అంట. సో అది ఈ సైడ్ ప్లేన్ లో మాత్రమే పాసిబుల్ అవుతుంది కాబట్టి సైడ్ ప్లేన్ ను తీసుకోవాలి. సో సైడ్ ప్లేన్ తీసుకున్నప్పుడు మనకు డి బార్ ఏమవుతుంది, డి బార్, రైట్, సైడ్ ప్లేన్ రిప్రజెంట్ చేసే యాక్సిస్ డిఆర్ అండ్ దాని యొక్క యూనిట్ వెక్టర్ ఏఆర్ అవుతుంది. ఓకే, సిమిలర్లీ, రైట్, ది సర్ఫేస్ దట్ ఈస్ రిప్రజెంటింగ్ ఇస్ డిఎస్. సో సేమ్ ఇక్కడ ఆర్ తీసుకున్నాం కాబట్టి దీన్ని కూడా ఆర్ లోనే తీసుకోవాలని చెప్పాము, రైట్. అదే ప్లేన్, నార్మల్ ప్లేన్ అదే అవుతుంది కాబట్టి డిఎస్ఆర్ మనకి cylindrical coordinate systems, as per cylindrical coordinate systems, right, DSR can be written as R, okay, R d phi dz AR. Okay, like this. Now we take the dot product of this, d bar dot ds bar. Okay, so d bar dot ds bar ఏమవుతుంది, right? So AR dot AR is 1. Okay, AR dot AR is 1. So remaining magnitudes get multiplied. So dr r d phi dz. This is the expression that I get. One second, ma. Somebody has sent a message. Okay. No issues. Okay. So right, clear with this. Okay, so this is the d bar dot dsr bar is like this. Okay, so d phi dz. Okay, dr r dz. Now we have to take the integral, right? Surface integral of this is d bar dot dsr is equal to integral dr r d phi dz. ante kada, this is the expression. Okay, right. Now this is equal to, right, this is a double integral. Forget about this side, ఈ సైడ్ గురించి మర్చిపోండి, ఓన్లీ ఈ సైడ్ చూద్దాం. ఓకే, ఈ సైడ్ ఏమవుతుంది, డిఆర్ అండ్ ఆర్ఆర్ కాన్స్టెంట్. ఓకే, విత్ రెస్పెక్ట్ టు ఫై మనం ఇక్కడ దేంతో ఇంటిగ్రేట్ చేస్తున్నాము, వీఆర్ ఇంటిగ్రేటింగ్ విత్ రెస్పెక్ట్ టు ఫై అండ్ విత్ రెస్పెక్ట్ టు జెడ్. ఓకే, ఫై అండ్ జెడ్. సో ఇఫ్ ఐ టేక్ విత్ ఫై, డిఆర్ అండ్ ఆర్ఆర్ constant. Similarly, with respect to z also, these two are constant. Okay, so if I put them out, right, okay, d phi dz, this is what we get. So because it's a surface integral ante double integral తీసుకోవాలి. There are two integrations that we need to do. One is with respect to phi, other is with respect to z. So this is equal to dr r, right? Okay, so first is integral d phi, integral d phi integral d phi integral dz ante kada. So this is equal to dr r into what is the integral of d phi? Phi అవుతుంది. Okay, okay, integral of d phi is phi, and what are the limits of phi? From 0 to 2 pi. Okay, 0 to 2 pi. Similarly, what is the integral of dz? Z అవుతుంది. What are the limits? Limits ante z represents, what is the z? Z represents the height axis. So this is representing the height of the Gaussian surface. So what is the height of the Gaussian surface? H kabatti 0 to h raskuntam. Okay, clear, understood? So this is the thing, right? Now therefore this is equal to, ఇప్పుడు ఏమైంది? This is equal to, so integral d bar dot ds bar is equal to, right, what I get? ఇదేమో dr అవుతుంది, ఇదేమో r అవుతుంది, right? This is phi. Phi లో నేను లిమిట్ సబ్స్టిట్యూట్ చేస్తే 2 pi minus 0 అంటే 2 pi అవుతుంది. ఓకే, అండ్ z లో లిమిట్ సబ్స్టిట్యూట్ చేస్తే 0 to h అంటే h అవుతుంది. ఓకే, క్లియర్ కదా? సో దిస్ ఇస్ ఈక్వల్ టు, రైట్, dr r 2 pi h. Okay, అయితే the left side of the expression integral d bar dot ds bar, this is nothing but psi. This is nothing but psi. Okay, so the psi is equal to, I'll get expression like this. This is the expression that I get. Psi is equal to dr into r. So ఇందులో నాకు unknown ఏంటి? dr. dr is equal to psi by 2 pi h r అవుతుంది. Okay, so this is the first expression. dr is equal to psi by 2 pi h r. క్లియర్ కదా ఇంతవరకు? రైట్. తర్వాత యాజ్ పర్ గాస్ లా అంటే ఒకవేళ మనకి psi ఇచ్చారనుకోండి, psi ఇస్తే డైరెక్ట్ గా అంటే if we know what is the total flux produced by that combination of charges or the infinite line charge, we can directly calculate the formula from this. Okay, we can directly calculate dr bar calculate చేయొచ్చు, dr calculate చేయొచ్చు, దాని నుంచి మనం dr bar చేసుకోవచ్చు. ఓకే, d bar చేసుకోవచ్చు. అదే మనకు ఒకవేళ psi కాకుండా టోటల్ చార్జ్ ఎన్క్లోజ్డ్ q ఇచ్చాడు లేదా రోయల్ ఇచ్చాడు, ఇఫ్ ఎయిదర్ q ఆర్ లైన్ చార్జ్, కాబట్టి లైన్ చార్జ్ డెన్సిటీ ఇచ్చాడు అనుకోండి, ఇన్ ఎయిదర్ కేస్ మనకి ఏమవుతుంది? dr is equal to, right, what we write is, so if q is given as per Gauss law, psi is equal to q కదా, so dr is equal to q by 2 pi h r. Okay, dr is equal to q by 2 pi h r అవుతుంది. Okay, if rho l is given, then I can write for a line charge density, right, for an infinite line charge. ఇదేంటంటే ఫైనైట్ లైన్ చార్జ్ కాదు, ఇన్ఫైనైట్ లైన్ చార్జ్. ఇన్ఫైనైట్ లెంత్ ఇన్ఫినిటీ ఉంటుంది. సో కాబట్టి దాన్ని మనం ఎక్స్క్లూడ్ చేస్తే dr is equal to rho l by 2 pi h r. ఇక్కడ లెంత్ rho l అనేది చిన్నగా రాసుకొని లెంత్, రైట్, l అనుకోవచ్చు లేదా వదిలేసేయచ్చు. దిస్ విల్ బి ద ఎక్స్ప్రెషన్ దట్ వీ వాంట్ టు గెట్. ఓకే, అండర్స్టూడ్? I think now it is clear, right? So this is how we can calculate, right? Identi, this is dr, not dr bar. d bar kaadu, dr. dr ante magnitude. Okay, magnitude of d along r. మనకు కావాల్సింది ఏంటి? d bar కావాలి. d bar ఎలా వస్తుంది? మనం ఏమనుకున్నాము? d bar is nothing but dr into ar అనుకున్నాం. సో d bar is a vector, డైరెక్షన్ కూడా కావాలి. సో dr ఏదైతే మనం వచ్చిందో ఆ dr రాసి rho l by 2 pi hr into ar bar or q by 2 pi hr into ar bar రాస్తాం. ఓకేనా? క్లియర్ కదా? సో దిస్ విల్ గివ్ us డైరెక్షన్ అండ్ థింగ్. ఓకే, ఎనీ మోర్ డౌట్స్? ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా? ఎనీథింగ్ ఎల్స్ యూ వాంట్ మీ? వీడియో స్ట్రక్డ్ సార్. ఓ, ఇస్ ఇట్? వీడియో ఇస్ నాట్ కమింగ్? Is it is the video stuck for everybody? Can you please comment once, somebody?
No, sir.
Oh, no, sir. Okay, okay, right. Shall I continue? Is this okay? Just comment. Are you getting the video? Are you able to see it? Yes. Shall I continue? Yeah. Okay, fine, right. Okay, so this is the expression for d bar of the infinite line charge, right? Similarly, for any given thing, we can calculate the same procedure. We can calculate for the flux density can be calculated, right, for any kind of charge, right? So what I want you is, because I cannot take right all that time. It is taking a lot of time, right? So I cannot calculate the other two also. So what I want is, I want you to calculate, right, the d bar using the similar procedure for an infinite sheet of charge. Infinite sheet of charge. Okay, so already I have told you this, how we can calculate electric field intensity using this in the Coulomb's law section, right? Coulomb's law చెప్పినప్పుడు మీకు ఆల్రెడీ ఇది చెప్పాను ఎలా క్యాల్కులేట్ చేయాలన్నది. సో అదే తీసుకొని ఇన్ఫైనైట్ షీట్ ఆఫ్ చార్జ్ తీసుకొని, సో ఆ ఇన్ఫైనైట్ షీట్ ఆఫ్ చార్జ్ కి రైట్ డి బార్ ఫైండ్ అవుట్ చేయండి. ఓకే, సో అలాగే right, this is one homework. Other homework for you is spherical shell of charge. ఇది కూడా మనం డిస్కస్ చేసాము, spherical shell of charge. ఓకే, సర్క్యులర్ రింగ్ అని చెప్పి ఉంటాను నేను. సో అలాంటిదే spherical shell of charge. ఓకే, సో సర్క్యులర్ రింగ్, రైట్? ఓకే, సో one will be like this, right? Sheet of charge అంటే ఇలా వచ్చేస్తుంది, like this, a two-dimensional sheet of charge, infinite duration. సో దీనికి క్యాలిక్యులేట్ చేయండి, ఇన్ఫైనైట్ ఏరియాకి, ఇన్ఫైనైట్ షీట్ ఆఫ్ చార్జ్ కి. అలాగే స్పెరికల్ షెల్ ఆఫ్ చార్జ్, స్పెరికల్ షెల్ ఆఫ్ చార్జ్ అంటే ఇట్ విల్ బి సంథింగ్ లైక్ దిస్. ఓకే, సో రేడియస్, సమ్ ఇన్ఫైనైట్ రేడియస్ ఉన్న ఒక రింగ్ ని మనము షెల్ ఆఫ్ చార్జ్ అంటున్నాం. ఓకే, సో ఈ రెండింటికి కూడా మీరు సేమ్ ప్రొసీజర్ అప్లై చేసి చేయండి. ఇఫ్ యూ డోంట్ గెట్ ఇట్, okay, I will again try to explain. Okay, no issues, right? In the next class, if you don't get the expressions of t bar for this, I will definitely explain. Okay, so these two are homework for you. Okay, so we have already done this in the Coulomb's law, right? Okay, now I want you to do that using Guass law. Similar thing using Guass law, same steps. ఇప్పుడు మనం ఏదైతే తీసుకున్నామో, రైట్, అదే టైప్ ఆఫ్ స్టెప్స్ తీసుకొని చేయండి. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఇది ఉంది, దిస్ షీట్ ఆఫ్ చార్జ్, రైట్? సో దీనికి గాసియన్ సర్ఫేస్ ఏం తీసుకుంటారు? రెక్టాంగులర్ బాక్స్. ఓకే, సో రెక్టాంగులర్ కోఆర్డినేట్ సిస్టమ్ తీసుకొని చేస్తాం. అలాగే ఫర్ దిస్ స్పెరికల్ షెల్ ఆఫ్ చార్జ్ ఉంది, దిస్ స్పెరికల్ షెల్ ఆఫ్ చార్జ్, ఫర్ దిస్ వీ కెన్ టేక్ ది గాసియన్ సర్ఫేస్ యాజ్ ఏ right sphere. Okay, and the coordinate system is spherical coordinate system. Okay, తీసుకొని చేయొచ్చు, రైట్? చేయండి. ఓకే, ఒకవేళ ఏమైనా డౌట్ వస్తే, ఏదైనా ప్రాబ్లం ఉంటే నెక్స్ట్ క్లాస్ లో చూద్దాం. ఓకే, సో దీస్ టూ ఆర్ హోంవర్క్. ఓకే, సో యూ సాల్వ్ ఇట్ ఆన్ యువర్ ఓన్. ఓకే, బట్ డెఫినెట్ గా సాల్వ్ చేసుకోండి, ఎందుకంటే రైట్, యాజ్ ఐ టోల్డ్ యూ, గాస్ లా లో మనకి క్వశ్చన్ అడిగే ఛాన్సెస్ దీనిపైనే ఉన్నాయి. ఈ మూడిట్లో కూడా, అంటే మీకు కూలుమ్స్ లా కానీ గాస్ లా కానీ, రైట్, ఈ త్రీ సర్ఫేసెస్ ఏవైతే స్పెషల్ సర్ఫేసెస్ ఉన్నాయో వీటిపైన ప్రాబ్లం అడగకపోవచ్చు, డెరివేషన్స్ అడుగుతారు. ఓకే, సో కూలుమ్స్ లా కూడా సేమ్, మీకు కూలుమ్స్ లా చెప్పినప్పుడు కూడా నేను చెప్పాను, ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఆఫ్ ఇన్ఫైనైట్ లైన్ చార్జ్, ఇన్ఫైనైట్ షీట్ ఆఫ్ చార్జ్, స్పెరికల్ షెల్ ఆఫ్ చార్జ్. అలాగే గాస్ లా లో కూడా, రైట్, ఈ మూడు ఎగ్జాంపుల్స్ కి క్వశ్చన్స్ ఎక్కువగా అడుగుతారు. ఓకే, సో కాబట్టి నా రిక్వెస్ట్ ఏంటంటే, యూ ట్రై టు సాల్వ్ దెమ్. ఓకే, బికాస్ టైమ్ ఇస్ నాట్ పర్మిటింగ్, ఐఎమ్ నాట్ డిస్కసింగ్ దెమ్, అదర్వైజ్ ఐ వుడ్ హావ్ డిస్కస్డ్. ఓకే, సో అది రైట్. I hope that okay, you will do it, right? Right. Now let us go to the next topic, that is the relation between d bar and e bar, right? D bar and e bar. Okay, d bar ki e bar ki relation enti. Okay, it's a simple one, right? What is d bar? D bar ante flux density, e bar ante electric field intensity. ఈ రెండిటికి రిలేషన్ ఏ విధంగా ఉంటుంది, రైట్? సో చూద్దాం. ఓకే, ఆల్రెడీ నేను ఐ హావ్ టోల్డ్ యూ ద ఎక్స్ప్రెషన్, దట్ ఈస్ d bar is equal to epsilon into e bar అని వస్తుంది. సో అది ఎలా అనేది డిరైవ్ చేద్దాం, ఒక సింపుల్ డెరివేషన్. సో ఫస్ట్ లెట్ us assume a point charge. There is a point charge of q అనుకుందాం. Okay, a simple point charge. A simple point charge is there. This charge, the charge of this is value is q. Okay, now I am considering a Gaussian surface around this charge as a sphere. Okay, so I consider a sphere or a circle, right, around this charge as a Gaussian surface. Okay, let the right radius, okay, the radius of this whatever the sphere that I have considered or the circle that I have considered is r anukunnam. Okay, right, let us consider it as r. Okay, now that the flux density, right, let us assume that the flux that is the total number of flux lines produced or right, or the flux lines that we get out of this entire sphere is psi anukunnam. Okay, the number of flux lines, the total number of flux lines that are produced are psi anukunnam. Okay, so in such case, right, flux density em raskochu, d bar is equal to, right, d bar is equal to psi by, right, and what is the formula for d bar? D bar is the total flux divided by the surface area. So total flux is psi and the surface area, right? Okay, so psi by s. S is the surface area. Now here the flux is represented by psi, and surface area ante, what is the surface area of the sphere? Sphere or a circle, right? The surface area of a sphere is 4 pi r square. Okay, so d bar is equal to, right, what I get is psi by 4 pi r square. Okay, now as per Gauss law, okay, if I take a Gaussian surface, then the flux of the Gaussian surface will be equal to the charge. Ante kada, the flux produced in the Gaussian surface will be equal to charge. So this will be q by 4 pi r square. Okay, so I'm repeating it. Malli okkari cheptanu. Malli em chestunnamo ante, what I am trying to do is I'm trying to get the relation between d bar and e bar. D bar is the flux density, e bar is the electric field intensity. ఈ రెండింటి మధ్యలో ఒక రిలేషన్ ను మనం డిరైవ్ చేస్తున్నాం. ఓకే, సో దానికోసం ఏం చేస్తున్నా అంటే, ఫస్ట్ ఐఎమ్ కన్సిడరింగ్ as small point charge. Okay, let this point charge have a value of q అనుకుందాం. Okay, around this point charge I am considering a Gaussian surface which is a spherical surface. Okay, a sphere. This is my Gaussian surface. Okay, a sphere. Okay, so this Gaussian surface has a radius of r. The sphere radius of the sphere is r. Okay, now, right, now if psi is the total flux, then the flux density can be written as psi by s. Ante kada, total flux by total surface area, right? So ikkada manaku oka doubt ravali, sir, you said that the flux should be calculated in normal direction. Okay, so normal direction లోనే క్యాలిక్యులేట్ చేస్తున్నాం. అంటే psi అనేది టోటల్ ఫ్లక్స్ ఏదైతే ఉందో, రైట్, Gaussian సర్ఫేస్ ఈ స్పెరికల్ గా ఇలా ఉంటుంది కాబట్టి, రైట్, అలాంగ్ ఆర్ డైరెక్షన్ లో వచ్చేవన్నీ కూడా నార్మల్. ఓకే, సో కాబట్టి, రైట్, ఒక సర్కిల్ లాగా తీసుకుంటున్నాం. రైట్, సో సర్కిల్ స్పియర్ ఏదైతే ఎన్క్లోజ్ అయిందో, ఇలా స్పియర్ ఉంటుంది అనుకోండి, నార్మల్ డైరెక్షన్ ఏమవుతుంది, రైట్, దిస్ ప్లేన్, దిస్ సర్కిల్, రైట్. So the circle that I am considering. Okay, so therefore the surface area of the circle is 4 pi r square and psi by 4 pi r square అవుతుంది. ఓకే, క్లియర్ కదా? తర్వాత psi అంటే ఏంటి? q. ఓకే, as per Gauss law ప్రకారము we can write psi as q. So therefore d bar is equal to q by 4 pi r square. Now what is the direction? Direction will be in the direction of the normal surface, that is r axis. Okay, so d bar is equal to q by 4 pi r square into ar bar. Okay, na? So we already know what is e bar. What is e bar? Because of this point charge, oka point charge undanukondi at a particular place, let's say at a distance of r ane distance lo oka particular point undi. Ee point daggara naku e bar ela vastundi, right? Basically formula, right, as per Coulomb's law, q by 4 pi epsilon into 1 by r square ar bar. Ante kada, right? Okay, so e bar is equal to q by 4 pi epsilon 1 by r square into ar bar. Okay, so this is the electric field intensity. If I calculate using Coulomb's law at a distance r, the electric field intensity is this value. Okay, ante kada, q by 4 pi epsilon into 1 by r square ar bar. Okay, because of this point charge. For the same point charge, if I take the Gaussian surface and calculate the flux density, then I'll get the flux density as d bar is equal to q by 4 pi r square into ar bar. So therefore, if I take the relation between this, so d bar can be taken as epsilon into e bar. అంతే కదా. సో ఇఫ్ ఐ మల్టిప్లై విత్ ఎప్సిలాన్, ఇక్కడ మల్టిప్లై చేస్తే రైట్ నాకేమొస్తుంది, epsilon into e bar multiply చేస్తే epsilon gets cancelled, q by 4 pi r square ar bar, that is nothing but d bar. Okay, so this is the relation between, right, relation between the d bar and the e bar. Okay, I hope I'm clear, right? So it's a simple concept. ఈ derivation మనకు ఎక్కడ అడగరు, only thing is we have to remember this relation. Okay, so if I know d bar, I can calculate e bar as d bar by epsilon. ఓకే, ఈ రెండు రిలేషన్స్ వల్ల మనము ఏంటంటే we can interchange them and we can use them, right? సో d బార్ క్యాలిక్యులేట్ చేస్తే e బార్ క్యాలిక్యులేట్ చేయొచ్చు, లేదా e బార్ తెలిస్తే d బార్ క్యాలిక్యులేట్ చేయొచ్చు. ఓకే, ఎలా వచ్చింది రిలేషన్ అంటే ఇది, ఒక పాయింట్ చార్జ్ తీసుకున్నాను, ఐఎమ్ కన్సిడరింగ్ ఏ Gaussian surface around this point charge, right? So I'm considering a Gaussian surface as a sphere, so total flux is psi, surface area is s. So surface area of a sphere or a circle is nothing but 4 pi r square. Okay, so I'll get like this. Okay, so therefore the relation between d bar and e bar